Excellent. Well, thank you for the opportunity to be here. We'll have a pretty intimate session today. My name is David. I work on a project called Lit Protocol, and we'll just kind of go through this. Some of these ideas potentially be familiar, but some of them won't be, maybe, and there can be some interesting stuff that we get into. And so the topic that we're going to talk about is like a decentralized programmable keys that live in custody of a distributed network, and talk about some of the technologies at play here. But before we jump into that, just like to set some context, I think one of the most interesting ways to think about Web3 is it's kind of like email in that people have applications and are all interfacing with the same underlying protocol in the same way that one of us might be on Proton Mail, one of us might be on Google Mail, one of us might be on Microsoft Mail, but we can't email each other because we're using the same underlying protocol. But before we jump into Web3, like back to Web2, there's basically this paradigm where individuals interface with platforms, and then the platforms exchange data and money about those individuals. And this is like where the whole world of ad tech lives, for example. And of course, in our Web3 world, we have the notion of an asymmetric key pair. This is all basic stuff that you know, but it gives you the ability to encrypt and decrypt messages, as well as sign things like transactions, which creates kind of the Web3 paradigm, whereby people use a key as the mechanism to interact with distributed networks. And you kind of start to see that the money and the data is on the other side. And the human being, the individual, has some interaction, whether it's around like selective disclosure and consent or self-custody over that data and those finances. And so what we are building is a threshold cryptography enabled network that basically uses some core technologies. One is called like a distributed key generation, whereby the nodes come together and they create new private keys, but none of the individual nodes has that whole private key, has that whole curve. Basically, the way that it works is that in threshold cryptography, you have a finite field. The nodes, which are called key shares in the threshold cryptography context, represent points along that curve, and you can derive the underlying secret by knowing a threshold of those points. But very interestingly, it's not just a matter of being able to reproduce the underlying key. Those key shares, the points on that field, can sign off with what is called a signature share. Oh, great, we got some more people coming in, which is called a signature share or a decryption share, to basically use the underlying key that's held in this distributed custody for some specific operations like signing, like encrypting. And so, yeah, what we've done is basically built a network for people to do just that. And we'll go through some of the docs in a second, but can first kind of go through the high level. And so this is kind of like what Web3 looks like with more keys. Obviously, you have the notion of a custody key using a vendor like Coinbase or FTX. And what we've got here is this distributed key management network that in turn lets you interact with the decentralized state machines, whether they're ledgers or storage networks. And so just like any key, this network provides two main services, which is the encryption and the signing, which we can generally categorize as read and write. And I'll take you through how both of these work. On the read side, basically the network is used to provision decryption keys to users. So let's say you have a scenario where Alice encrypts some data and she says to the network, hey, only let the person who's a member of the Lion DAO decrypt this data. That decrypted data gets stored on IPFS or wherever. The symmetric key associated with that video, let's just say it's a video, maybe even this video, is encrypted to the lit network and associated with a set of rules. And I'll show you what those rules look like. On like an EVM chain, for example, you could say, somebody has to own a specific token, a specific NFT in order to decrypt that. And then so Bob, who's a member of the Lion DAO, and it doesn't necessarily have to be hold a token, it could be member of a DAO, or really any public data can kind of function as the access control list for the key provisioning. So Alice has encrypted that data and set the rule such that only the member of the Lion DAO can decrypt the data. Bob shows back up later on and says, I want to decrypt that data. He signs a message and sends that to the lit nodes. Each of the individual nodes does a call down to the blockchain and says, is Bob a member of this DAO? And if so, that node creates a decryption share, which you can kind of think of as like an authorization, which gets sent to Bob. And Bob collects those shares in his browser in the client. And once he collects a threshold of those shares, which in the case of this network is 2/3. Hey, Wendy, in the case of this network is 2/3, Bob is able to decrypt that initial symmetric encryption key that Alice encrypted, pull that data down from IPFS, decrypt that, and yeah, all of a sudden now we have a mechanism for essentially validating some identity. In this case, an identity is a member of Lion DAO, and then provisioning a decryption key to that user. And what we have here is now a world where you can store private and permission data on the open web. And a lot of the use cases that we've seen for this are things like a lot of things around Web3 social. Like Lens protocol is a smart contract based social protocol. Orbis.club is a ceramic, which is a decentralized database system for social media. And both of those networks are using Lit to do the key provisioning, whereby it says, if this person has this token, let them read this chat or read this DM. And the kind of the distinction here between what you would find on like Signal app, which is identity-based encryption, where you're doing a Diffie-Hellman handshake, and the parties that are going to be decrypting are known. Here, the kind of the main advantage is that the parties that are going to be decrypting are dynamic, can constantly be changing. People can be buying and selling NFTs, moving in and out of DAOs, can create sophisticated Boolean logic. And at the time that somebody wants to decrypt something, they need to prove through signing a message that they, in fact, have the right to be provisioned that key for whatever that content is. We've also seen a lot of stuff around intellectual property, token gating websites, token gating paper contracts in like biomedical pharmaceutical networks, token gating like videos and pictures, token gating. And when I say token gating, I mean this in like a very general sense. I just mean like gating based on on-chain conditions, but also like data in the context of data marketplaces for like marketing data and stuff like that. And then to me, what this image kind of represents is authorization. I think the end game here is really basically creating the Web3 version of what we see today with sign in with Google. As you may know from when you sign in with Google, there's a consent screen where the application gives you a prompt and says, we would like access to your contacts and calendar. And, you know, typically people just click yes. But what we're starting to see developed, and there's plenty of opportunity to build infrastructure and standards around, and, you know, there's some things around verifiable credentials and other teams that are working on this too. But there's still tons of opportunity here, is for that to be a first party relationship between the user and the application, whereby they're giving that application specific and rights or selective disclosures to decrypt some of their data. So you log into a website with your wallet, that wallet or DID, whatever it might be, has some private data associated with it. And the user gets a prompt that says, this app wants to decrypt your calendar. And then you can grant them the right to do that decryption. So that's kind of lit for encryption, this read side. I'll see if there's any questions before I kind of go on to write. If not, okay, yeah, feel free to jump in at any time too. We can keep this conversational. So the other piece of what you can do with a key, of course, is signing. And that is what we're looking at here, which is a mechanism, and I'll show you an example, to basically write some JavaScript code whereby the ability to do an ECDSA signature is one of the JavaScript functions. An ECDSA, as you probably know, is like the signing algorithm that's used across the Cosmos ecosystem, the Ethereum ecosystem, the Bitcoin ecosystem, the IPFS data storage ecosystems, as the methodology by which the key can talk to the state machine. And so what we're looking at here is the ability to put the signature into a program and essentially create automations for signing. And so the way that works specifically is that code gets uploaded to a specific content ID on IPFS, which is an immutable address. And then when the nodes get triggered and said, hey, run this code, in the same way that we looked at before, where in the earlier case, the nodes were reading the chain for access control, here they're pulling the code from IPFS, doing the computation for that code, and then rather than producing a decryption share, which we talked about before, in this case, they're producing a signature share. And once a party aggregates those signature shares, whether it's the user themselves or some third-party executor that they're using to push the transaction to chain, they can basically create human out-of-the-loop signing. So to talk about some examples for that and to kind of ground that in some use cases, like the state of the art for a lot of DeFi things today, whether you're a liquidity provider or whether you're like, maybe we use the example of staking DeFi tokens. If you stake some tokens, the current state of the art is you sign up for some alerting service that when the price starts to drop, you get a text. You have to wake up in a cold sweat in the middle of the night, run over to your ledger, unstake, sell it for USDC on a DEX in order to move out of the position. But what we're talking about in the context of Web3 automation here is a world where you have this JavaScript program that's listening to the price feeds. And at the time that, let's say your OHM tokens drop more than 20% in a 2-hour period, that kicks off a program that unstakes the tokens, sells them for USDC on a DEX, and sends them to your Ledger wallet, all without the individual in the loop, kind of in the context of automation. The other thing that's really interesting here is thinking about these kind of cloud wallets associated with mobile apps. Obviously, there's some interesting stuff happening with Apple and their take on NFTs, but starting to think about what it looks like to have like a mobile SDK that developers can start building on, where the wallet and authorization functionality is built in, which kind of brings me to this last graphic here, which is now that we're kind of in the mindset where the key is in the cloud, so to speak, held in this distributed context with multi-party computation and threshold cryptography, hooking up more authorization mechanisms that the majority of people are used to, like Google Auth, text message auth. There's something called Web Authn, which is the new kind of like passwordless standard that Google and Apple have agreed upon. And it's said to be kind of being rolled out by January, so by the end of the year. And so we're seeing a lot of people kind of building in this regard. I think other really interesting things here are at the intersection of MPC wallets, which is what Lit is, and also account abstraction wallets or smart contract wallets. So a lot of kind of interesting work happening around essentially using MPC as a methodology for doing decentralized account recovery to smart contract wallets. But really, over the course of the next year, the capacity for onboarding any individual into Web3 is going to dramatically improve, largely thanks to MPC and smart contract wallets. And so, yeah, I guess the thing that
David,
yes, please.
Could you touch on the in the previous slide, you mentioned Apple NFTs, and I didn't know like what is their take on it.
Yeah,
I'm not in the loop on that.
They just did this whole. I don't know what exactly their thing is offhand. I can send it in the chat. Apple. Let's see. Yeah, this was just from a few days ago.
Okay.
Yeah.
Got it.
Yeah. So we'll see what happens. We'll see if these rules stand up. But that's what I'm specifically.
And what is the role that Lit plays where like that wouldn't be an issue? At least that's really kind of how I was understanding it.
Yeah, so I mean, it really depends on how these rules are going to be enforced. Basically, the reason that I mentioned that here is just that, like, the mobile stuff is really, really interesting, but Apple, frankly, is dependency because obviously, like, Apple controls a lot of people's experiences on mobile. So who knows?
Right.
It may be an interesting thing that kind of like, if Apple is super intense about these rules and doesn't change them for years, maybe as a result, it forces the whole Web3 kind of community and industry to like double down into gaming as a result, which, is not ideal, right? Like the more is more. But that's a current constraint that is kind of having to be sorted out industry wide. And I'm sure people will figure out kind of clever things as we go. Or the alternative is just paying Apple their 30% cut, which is obviously the current state of things today.
Got it. Got it. Thanks.
Yeah. And yeah, I just wanted to kind of like end on some things that we think are really cool to build. And just share that we have like a grants program. We put a number of like builders in touch with venture capitalists who are leveraging this underlying technology of this like programmable key. It's really wide open, and there's just enormous amounts of opportunity. Talked a little bit about the account abstraction wallet. There's also the capacity to kind of use this thing as vaults, whether you want to like take some Bitcoin and trade it on Ethereum, connecting it up to other services like Wallet Connect. We also have this capacity with this PKP, is what we call the programmable key pair, is this kind of cloud signing capacity. There's the ability to do something that we call like mint grant burn, which is the ability to mint one of these new cloud wallets, grant it authority to sign based on some program, and then burn the underlying controlling NFT. And what you functionally have there is like an immutable cloud function. So you could like write code that determines, is this number prime, yes or no? And then you have like a fault tolerant guarantee that the results that you're getting back from that, almost kind of using it as a prover, is this number prime, yes or no? You just like send up a prime number, and then you get a result back, a signed result back of yes or no from this in a fault tolerant way. That's pretty fun. We've had some people kind of propose throwing blockchains into these keys and using the compute there, which is a pretty heady idea. We talked a little bit about user-owned data. To me, I think one of the really interesting opportunities there is like, definitely a huge fan of what like Lens and Orbis are up to with public social graphs, which is kind of analogous to Twitter. There's a huge opportunity in this space for a leader to emerge around private social graphs that treat somebody's friends list as their own kind of private property. Likely with tools like Ceramic or Polybase, and thinking about the friends list as an encrypted verifiable credential. Of course, like this is a whole other conversation. Then there's also the whole Jack Dorsey blue sky world that uses decentralized web nodes. And there's this whole other debate around like, where is user data going to get stored in the future? Is it going to be encrypted in public, or is it going to be on decentralized web nodes? As the truth will probably be diversity. It'll be a little bit of both, but really interesting to see what happens there. Another kind of interesting idea to put forward is that, what is happening with this programmable key pair thing is functionally making private keys something that are liquid, that are tradable. So the current state of the art today is like, if you have some ETH and you want to stake 32 ETH such that you're earning yield on it, you are locked up. That ETH is locked up. But if you stake that ETH from one of these PKP wallets, these MPC wallets, you could trade the underlying wallet. The wallet itself has liquidity. Another way to kind of conceptualize this is this kind of breaks the notion of soul-bound tokens, because the key pair itself is something that's liquid. So super interesting stuff to kind of get into around like gaming and NPCs and chatbots, where you can start to have automated interactions, signing transactions or interacting with smart contracts. So really excited about the handful of projects out there that are doing like full-on Web3 gaming, not just like Web 2.5, where they're like bringing NFTs into a centralized game, but have all of the interaction of the game on chain. So a lot of the privacy and automation stuff is really relevant there. But yeah, I would say that's an overview of what we're up to. And yeah, the docs, you can go to developer.litprotocol.com. We also have getlit.dev because it's funny. And yeah, I'll stop screen sharing for now, and maybe can see if there's some questions, and then we'll pause the recording. Chili has a question. How did we get into this project? Excellent question. So the genesis of this idea, basically, a few years ago, my co-founder Chris and I, and he's like a crypto OG. He started mining Bitcoin in 2011. He's one of the inventors of the first hardware wallets back then. It was a paper wallet printer, like a Raspberry Pi in a black box. You push a button and it prints out a new paper wallet. And so we had built this NFT marketplace that was kind of fully custodial, fully Stripe based. Frankly, we were on like a 2.5 year journey of navigating the idea maze. We raised money for a thing, shut it down, raised a little bit more angel capital, iterated through 3 or 4 different concepts, largely all focused on crypto. And so we spun up this NFT marketplace that was like Stripe based, fully custodial, on Polygon, super easy to use, and just had this prompt ringing in our head that like there's got to be something more to NFTs than just as kind of like digital art, which is an amazing use case. But the nature of the internet is that you have dynamic interaction, user generated content. And so I kind of like identified that as a problem area for just thinking and research on. And then there's always some like serendipity that happens with these things. But Chris during that time was really active in an NFT marketplace called Hit at Nook. It was on the Tezos blockchain. And they were the first ones to render HTML NFTs in the marketplace client. And as you guys know, an NFT is just a pointer that points to a file. The typical example that we run into is it points to a JPEG file, but can also point to an HTML file. And so it was about 2.5 years ago, Chris, we have our daily stand-up call. Chris goes, "Hey, Dave, check this out." And I'm like moving slider bars around on this NFT and go, wow, NFTs aren't just picture frames. They're like browser windows. Here's some HTML. I'm playing with it live. And so then we started to basically conceptualize the one's wallet full of NFTs, almost as if it was their metaverse lobby, and that like the different NFTs would be different portals to experiences. And inside of that experience, you would have user generated content, you would have social interaction, so on and so forth. And so we're like, okay, cool. That's like a really cool vision of the future. We should build that. But then the next prompt was like, well, how the heck do we make an NFT unlockable? So we like looked at what New Cipher was doing, now called Threshold Network, with proxy re-encryption. It wasn't quite right for our use case because we wanted somebody to be able to like set something up and then have it be accessed 100 years later and be like a totally non-interactive process. Was one of the design constraints that we set for ourselves. Also kind of looked a little bit at like what Secret Network was doing, but obviously there's like a big dependence on SGX and Intel in their current model. And we were more interested in kind of like things that were cryptographic solutions rather than vendor solutions. And then so we're kind of wrestling with this problem for a week. And then I remember where I was. It was right after I got my vaccine. I was like kind of getting stir crazy in California. And I went to Mexico just to kind of like hang out on the beach, continue working, good internet for the week. And Chris goes to me, goes, "All right, but the main thing is, where does the key live?" And almost as like a throwaway comment, I said, what if we use a network of nodes to custody the key? And then that really opened our eyes to this whole world of threshold cryptography, multi-party computation, proactive secret sharing that exists. We were able to go team up with a guy named Dr. Jason Morton, who was formerly a professor of applied algebraic geometry at Harvard, to kind of be the head of cryptography over here at Lit. And yeah, once we kind of came across the idea around thinking about the key as a programming primitive, it was very clear that you could use this for unlockable NFTs, but also for a lot more things, and basically turn this into the service that you see today, and we're obviously continuing to decentralize.
Can you talk more about the like you mentioned in a lot of like Web2 sites you can like log in with Google or log in with Facebook, and how
Right.
like Lit could serve as like a read service for that. Could you go into more on like what that looks like?
Yeah, I'll show you I'll send it in the chat. One group that's kind of working on it. So there's this group, Crebit. They're out of Central America. They're working on some stuff related to this, but basically, like I think the idea, and again, open question on where the data is stored. Is it on open tool like Ceramic, or is it on decentralized web nodes like Web5? But the general idea is that there is some database, again, with one of these two vendors, that users and other parties are writing to that database information about the user in the form of a verifiable credential, which, like, through the W3C standard is essentially just like a signed JSON linked data, is the standard that is being used there. And then so let's say you have like your email address, your shoe size, your friends list, the last 5 things that you purchased, and a bunch of other information about yourself. It's stored, let's just use the open web example. It's stored on Ceramic or Polybase in an encrypted format. You go log into a new website, and then that's where the consent flow happens. And because that data is sitting in public, once they have the key, they can pull that public data and know that about you and tailor your experience. And for me, what I really think that this makes this really interesting is it provides a much more networked view of the internet, because like the current paradigm is when you log into any website like Twitter, you're reading and writing to that application's database. But when you show up with your own table, some people have used the metaphor of like a data backpack to describe this. All of a sudden, you're not just reading and writing to that application's table. They are in turn writing and reading back to your table, and your table is in turn connected to all of the other applications and friends that you have. And so we start to basically kind of move from the notion of Web 2, which I think if you look at Google, you can largely characterize as like linked pages. That's what Google is doing, is crawling and seeing the cross-linking to something that already exists in the modern enterprise, which is like the notion of a data lake. And we kind of like move from this internet of linked pages to this internet of data. The folks at Ceramic like to call this the dataverse, as to describe this kind of like general concept of the new web, where you're showing up with your own table and people are interacting with you by reading and writing to your table. Does that kind of get at what you're asking about?
Yeah, it does. It does. I think the like linked pages idea compared to, I don't know. It does.
Chloe, Wendy, Hayden, any thoughts or questions? If not, no worries. Glad you're here. Yeah. Kelly asked about the risks. So basically the risks are the key being compromised, right? At the end of the day, like, this is, to use like a Web 2 analogy, lit is basically like the equivalent of what you would get with like Amazon Lambda functions plus the Amazon KMS, except without having to depend on a central authority and without the application developer being able to kind of like rug the key with their Amazon credentials. And so the main risk is the key being compromised, and the methodology for preventing that. And this is functionally the security model of the network, is basically 3 layers. The first layer is to generate the key through this cryptographic process of the distributed key generation, such that like the private key from a certain perspective never exists in its entirety. And frankly, I think by the end of the decade, like, chief information security officers all over the globe will be like, what? You have a full private key somewhere? That's like crazy. We're still at the very, very early days of threshold cryptography being used for specific Web3 use cases. But my expectation is that this will flow out to the rest of the kind of the economy as it relates to security professionals over the coming years. So layer 1, or the first layer, the full key never exists. The second layer is then, so now we're in a world where each of the individual nodes have their own private secret. And granted, you need to get a threshold of those secrets 2/3 of the network together in order to compromise the key. But the mechanism for preventing that is we've done a bare metal implementation with AMD's secure encrypted virtualization, which is a type of enclave. The reason that we went with AMD over Intel is that with Intel, this is like some small details, you have to register the attestation with Intel. They're a centralized provider. AMD does not have that requirement. And frankly, it's been really, really interesting talking to all of the cloud providers, OVH, Microsoft, Google, around being able to get the bare metal access. Some of them are more open to it than others. Some of them obviously want like their centralized management layer in the mix. So yeah, layer one, divide the key. Layer two, hide the key share through an enclave. And then the third layer is that the node operators, at least in the initial version of the network, will be named parties. So like folks like, we're talking to a handful of folks, names that you would know, some that I mentioned earlier, some more in the crypto space, will basically kind of like collectively provide this service. And so taking it from the bottom back up, you're saying here are named corporations that have signed a paper contract and put their reputation on the line for protecting this key. But even if there was somebody malicious at that organization, they'd have to break the enclave. And even if they broke the enclave, they would have to get 2/3 of the network together to also break the enclave and decide to collude. But that's the existential risk. And then the goal of what we're up to is doing everything we can to prevent that while still making it super easy to use for developers.
Could you touch on the second point with the AMD aspect? I just missed what you said there.
Yeah, so secure encrypted virtualization. I'll send you a link in the chat. Is a type of like secure enclave. I'll send you the link to AMD's stuff about it. And basically, it's a mechanism to do computation entirely in memory, such that the person who's operating that computer or node can't get access to that. You can think about like these enclaves as like a black box. And so all of the node's operations take place inside of this black box, such that the node operator can't get at their key share, which is but like developers can still use it. And the thing I mentioned about AMD versus Intel, just to round that out, was the fact that like AMD doesn't put themselves in the mix in the same way that Intel does.
Isn't Derivadex, are they doing something like that on their layer? If you know, I think they're using Intel, but
there's a lot of stuff happening with enclaves. So like enclaves have definitely gotten a lot more popular in maybe the last year and a half. Like Secret Network is basically a Cosmos chain inside of an enclave. This group called Fortanix, which is like a HashiCorp competitor, which is like a centralized key manager. They've announced a whole blockchain initiative where the key management is fully enclave based. I've seen a handful of people exploring like even putting like marketing email like SMTP servers inside of enclaves such that you could like do private marketing emails from a DAO and not let anybody kind of like steal the marketing list. So enclaves are pretty interesting. We obviously like aren't interested in being fully dependent on them, which is why we have this distributed key in the notion of the network. Because like there's a perspective where you can kind of think about security through layers. But it wouldn't surprise me if Derivadex is doing something with enclaves, but I'm not sure what their thing looks like.
Yeah, I remember this was like maybe like a year and a half ago reading about it. I didn't understand what was going on, but kind of sounded similar. I think it's pretty cool how you guys have a layered approach for security. I don't know, I was echoing some of the how Hyperlane they have that like cheese grater approach where like if you slip through one of the holes, the other security mechanisms will account for it.
Yeah, it's pretty fun. And I guess I'll stop the recording here in a second. But for anybody who's like watching this in the future, for anybody here, like basically, at least as of right now, just from the conversations that I'm having on a day-to-day basis, there's just a world of opportunity. There's like venture capital money sitting aside. There's huge things to build. So just like a general plug around like, I'm friendly. Let's talk about ideas if you want to like work on stuff together. But yeah, if there's no other questions, I'll stop the recording and then we can just kind of hang out for a bit.